Welcome back to my channel, students. We're going to solve the problems in exercise 7.6. So in exercise 7.6 there are 27 problems. So out of 27 I'm going to solve very important 5 problems. So these 5 problems will actually help us to solve the rest of the problems. So here we are now finding the factors of a given expression by using identities as a tool and manipulation as a tool. So in a previous video we have discussed a square minus b square tool that helps us to find the factors of a given expression, but in this class we are going to use the 3 identities along with manipulation. So our next problem is 9a power 4 minus 24 a square b square plus 16 b power 4 minus 256. So we have to find the factors of these given expressions. So how can you find the factors of given expression? We just have to make certain that we have to just bring the terms into one group so that we can able to solve by using these identities. For example, if I just bring all these terms into a group, for example, if I bring 9 a power 4 minus 24 a square b square plus 16 b power 4 into one group and minus 256 another group, right? Minus 256 is another group. It becomes two groups. Now what I'm going to do is I'm going to just bring this expression. That means I'm going to bring the terms, a few terms in this expression into an exponential form. For example, let's take 9. Here 9 can be written as 3 square and a power 4 can be written as a square to the whole square, right? For example, I can write this 9a power 4 as 3 a square to the whole square, right? So here you have a minus sign. We're going to keep minus sign. Now we have 24. So let's try 24 a square b square as it is. So later we're going to check is 24 a square b square or correct by using ab values. So we have 16 is a square number. That means 4 is a square number. So we are going to write 16b power 4 as 4b square to the whole square, right? Now if you observe this expression, I say that this expression absolutely looks like a square plus b square plus a square plus b square minus 2ab, right? It looks like a square plus b square minus 2ab. For example, if I take a as a 3a square and b as a 4b square, I'm going to check the middle term is correct or not. Okay, so 2 of 3a square times 4b square. So here 2 3s are 6, 6 4s are 24. We got 24 number a square b square. That means we got 24 a square b square as the middle term. That means here we got 24 a square b square. That means a and b values are correct. A or b values are correct. So the given expression is in the form of a square plus b square minus 2ab. So what is a square? So what is the value equal to a minus b whole square? Now I'm going to write a as 3a square minus b value as 4b square to the whole square. Here you have a minus sign, right? And observe this is a 256. This is a square number. If you just try to solve this, this is a square number. This is what kind of a square of a number? It is a 16, right? 16 times 16 is 256, right? So I'm going to write this 256 as minus 16 whole square. Now if you just observe, if I take this as a, if I take this as a b, it looks like a square minus b square. That means a square minus b square is a plus b into a minus b. Now I'm going to write this as a square minus 4b square plus 16 times 3a square minus 4b minus 16. So these are the product of two factors of the given expression. So how do we find this given expression? We found this given expression by grouping the terms. We just group the terms, then we solve the values within the bracket. We solve the values here within the bracket. So what do we got by solving the values within the bracket? That means we are just trying to find out is this values or just resembles like identities or not. So we just made a few of the terms into an exponential form. So we got this value which is absolutely certainly equal to our identity, which is a square plus b square minus 2ab. When the value is equals to a square plus b square minus 2ab, then we have to make this equal to a minus b whole square. So that is why we have taken a value as a 3 square and b value as a 4b square. So we have just equal to 3a square minus 4b square. Now here we have a minus sign, we have kept minus sign. So here we have the value, a number which is 256, which is 256 is a square number, first of all, right? When 256 is a square number, so we have what kind of a square number? What is the square number of 256? I mean, what is the square of a number of 256? 16 is a square number, so that is why I have written 16 square, right? 16 square is 256. So now if I just look this expression, the whole expression, it looks like, if I take this whole expression, it looks like a square minus b square. So I'm going to make this value into a plus b into a minus b. That means I have to make this value into product of two factors. So I got one factor, another factor. I have got one factor, I've got another factor. So these are product of two factors is equals to a given expression. So this is how we are going to solve a given expression problem. So our next problem is 96 minus 4x minus x square. So we are going to find the factors of this given expression by using identities and manipulation. Okay, so we are going to use this tools in order to find the factors of this given expression. So if you just look this expression, we cannot take the common from three terms by using the previous video, which is HCF method. So here the identity tool or identity method helps us to find the factors of a given expression. So if you rewrite this as minus x squared minus 4x plus 96, so you get this expression. Now what we are going to do here is we are just trying to manipulate. That means we are trying to create a number, make them believe that it existed without its existence. That means we are making it believe, but here the value does not changing, right? So if I just add with 4 and subtract with 4, the value doesn't change because it is getting added and then later it's getting subtracted, right? So now what I'm going to do now is I'm going to just group these terms into one group and another group, right? So if I just group minus x squared minus 4x, if I take this minus 4 here over here, it becomes one group, and another group 96 plus 4 into the another group. So now we got two groups, right? So here in this group, I'm going to bring out the sign outside, so it becomes minus of x squared plus 4x plus 4, and this as 96 plus 4 as 100, right? So x squared plus 4x plus 4, if I just rewrite this expression, and if I rewrite this 4 as x squared plus 4x plus 2 square, it resembles like a square plus b square plus 2ab, right? That means in order to check 4x, a middle term 4x, if you take a value as x and b value as 2, so 2 of x times 2 is 4x. That means ab values are correct. That means the expression is resembles like a square plus b square plus 2ab, right? Now what we are going to do is we are just making this expression into a plus b whole square, right? So what is a value? X is a value plus what is a b value? 2 is a b value. I'm making it whole square. So here we have a minus sign. I'm going to keep minus sign over here. So here we have a plus 100. So if I just turn this expression, it becomes if I just turn this expression, it becomes 100 I mean 100 minus x plus 2 whole square. That means if I write 100 in exponential form, it becomes 10 square minus x plus 2 whole square. That means this expression resembles like a square minus b square. If I take 10 as a, if I just take this term as a and this term as a b, it resembles like a square minus b square. So both are squaring, both terms are getting squaring. So now we have to make this expression equal to a plus b into a minus b, right? So we are making, what is the a value? We got 10 as a value. So 10 plus x plus 2 times 10 minus of x plus 2. That means 10 plus 2 is x plus 12. So we got one factor, another factor, minus x minus 2 plus minus 2. So 10 minus x minus 2 is how much? We got x plus 2, x plus 12 over here. So 10 minus x minus 2 is how much? It is 10 minus 2 is how much? It is 8 minus x minus 8 minus x plus 8, right? So we got the two factors over here. So these are the product of factors of given expression. So how do we find this expression? How do we found this expression? So we found this expression, we found this product of factors by using identities and manipulations. We used manipulation. That means we created 4 and we subtracted 4. That means the value, whole entire value does not change. It is equal to a given expression. But in order to convert this expression into an identity resemble, so in order to resemble this expression into an identity, we just make a manipulation. We just made a manipulation. That means we just take 4 and subtracted 4, but the value doesn't change. So why do we make this manipulation? Is because to make this expression into an identity, so that if an expression resembles like an identity, that means we are able to find the factors of a given expression. That is why we found the factors of a given expression. So our next problem is 4x power 4 plus y power 4. So here we need to find the factors of a given expression. Okay, we need to find the factors of this given expression. So how can you find the factors of this given expression? So if we just look at these two terms, they don't have common, so we cannot find the common. Like we cannot find this expression by using the previous video method, right? So we can only find these expression factors by using only identities and manipulation method. So how can we deal with such kind of problems? How can you deal with such kind of problems? If I just write 4x power 4 plus y power 4, if we use the manipulation, that means if I just add 4x square y square, and if I subtract 4x square y square, the value doesn't change. In order to bring an expression into an identity, just resemble like an identity, I have made this manipulation where the value doesn't change. I just made this manipulation is because to resemble like an identity, to solve the expression its factors, right? So what I'm going to do now is I'm just trying to consider this group. Now this becomes another group, right? After manipulation, we have to group them so that we can able to deal with that values. So I'm going to deal the values within the bracket of this term, right? So if I just write this values in exponential form as 4x power 4 can also be written as 2x square to the whole square, right? Plus y power 4 can also be written as y square to the whole square, right? Here I have a plus sign, and 4 can also be written as, so 4x power 2 y power 2 can also be written as 2xy whole square. Wait a minute. If I just write this as 4x square y square. So it's not like I'm not simplifying. I'm just trying to make this expression resemble like given formulas or not. I'm going to check. I'm trying to check. I'm trying to checking, right? So what I'm going to do now is keeping in the bracket, square bracket. Now you got 2x. If when you write a few terms of this expression as the exponential form, when you write this whole term as 2x square to the whole square and y power 4 as y square to the whole square, and plus as it is this term as it is as 4x square y square, if you determine this term looks like a plus b whole square. That means it looks like a square plus b square plus 2ab. So if you just take a value as 2x square and b value as, I'm going to write over here, so a value as 2x square, b value as y square. I'm trying to check 4xy square, is this values are equal to 2x square y square or not. So 2 times of 2x square y square, so 2 2s are 4x square y square. That means you are getting the middle term as 2ab, which is 4x square y square. That means ab values are correct. That means it resembles like this whole expression resembles like a square plus b square plus 2ab. Now this expression looks like a square plus b square plus 2ab. Now we can convert this expression into a plus b whole square, which is 2x square plus y square, sorry, 2x square y square to the whole square, right? You got this expression. Now here you have a minus, we are keeping a minus, and here you have a 4x square y square, right? What we are going to do here is we are just trying to rewrite this expression into an exponential form as 2xy whole square minus 2x square plus y square to the whole square. This expression looks like a square minus b square. Now what we are going to do is we are just trying to find the equal identity, which is a plus b into a minus b, right? What is a value? 2x square plus y square plus 2xy times 2x square plus y square minus 2xy. So we got product of two factors of a given expression. There is nothing to solve within the bracket. So when you are unable to solve the values within the bracket, is nothing but you found the product of two factors of a given expression. So this is the product of factors of a given expression. So our next problem is x plus 2 whole square minus 6 of x plus 2 plus 9. So we are going to find the factors of this given expression. So many of you will say that there are common terms x plus 2, x plus 2. You say that we can take common, we can group these two terms and separate this 9 as unique, so that we can find the factors of this given expression, but that doesn't work. So grouping terms, when you want to group a term, we have to group it for one term and another term. If you group this and this term, then what about 9? It will be alone itself. So that doesn't make any sense, right? We have to just group another term with 9, so that makes sense, so that we can find the factors of a given expression. So here we cannot take common, there is no common, right? If there is no common, the identities and manipulations helps us to find the factors of this kind of problems, right? So what we are going to do now is we are just trying to find out by using, if you write x plus 2 whole square and minus 6 of x plus 2 plus 3 square, if you just if you observe this expression, it looks like a minus b whole square. That means it looks like a square plus b square minus 2ab. So what is a square? X plus 2 is a x plus 2 whole square is a value, and 3 square is a b value. So if a is x plus 2 and b value is a 3, so 2 of x plus 2 times 3 is how much? 3 2s are 6, so 6 of x plus 2. What we are getting the middle term? 6 of x plus 2. That means a and b values are correct. The whole expression resembles like a square plus b square minus 2ab, right? So now it just resembles like a square minus b, a square it resembles like a square plus b square minus 2ab, which is equal to a minus b whole square. What is a value here? Here the a value is x plus 2 minus, what is b value? 3 x plus 2 minus 3 whole square. So that means x plus 2 minus 3 times x plus 2 minus 3, or the product of factors. If you write into a product of factors, you will get x plus 2 minus 3 times x plus 2 minus 3. That means x minus 1 times x minus 1, or the product of two factors of a given expression. So this is how we are going to find the factors of a given expression. So how do we found this expression? We just try to this expression, if we write 9 in an exponential form, it resembles like x plus 2 whole square minus 6 of x plus 2 plus 3 square. That means it just looks like, if we consider this whole value as a square, if we consider this value as a b square, so it looks like, and if you consider this as a minus 6 of x plus 2, it looks like, that means minus 2ab. If this looks like a square plus b square minus 2ab, which is equals to a minus b whole square. So that means we got product of two factors. So if we simplify the values within the bracket separately, we get x minus 1 as one factor, x minus 1 as another factor. We got product of two factors of a given expression. So this is how we are going to find the factors of a given expression. And thank you friends, thank you for watching. So those who didn't subscribe, make sure you subscribe, like, share, subscribe. So we are going to find the new problems, new chapters. We will teach you new chapters, new problems that are very troublemaking. So thank you for watching.